this video, we will be discussing about minimum number of operations to move all balls to each box. You have n boxes. You are given a binary string boxes of length n, where boxes of I is 0 if the ith box is empty and 1 if it contains one ball. In one operation, you can move one ball from a box to an adjacent box. Box I is adjacent to box j if the absolute of I minus j is equals to 1. Note that after doing so, there may be more than one ball in some boxes. Return an array answer of size n, where answer of I is the minimum number of operations needed to move all the balls to the ith box. Each answer I is calculated considering the initial state of the boxes. So what they are saying is that in the input, we are given a binary string of boxes. Each of these index is denoting a box, right? Now, if at that particular index we have a 0, then that means that the box is empty. And if it has a 1, then that means there is one ball present in that particular box, right? Now, what we need to do is that we need to return an array of answer, right, which will be of the same length as the box's string, right? Now, in this, for each of the index, we need to identify that how many moves will be required to move all the balls to this particular box, right? And then whatever are the number of moves required for moving all the balls to this particular box will be the answer for this particular index inside our answer array, right? And the moves are on the basis of that. Let's suppose if I am moving this ball and I want it to be here, so this will be counted as individual moves, right? I cannot move this directly to this particular box, right? It can only go to is its adjacent box, and moving to the adjacent box, the moves will be counted as one, right? So if we see over here for the index 0, we need to move all the balls in this particular box, right? So this is going to take one move, right? Then this is going to take 1 plus 1, that is 2. So total 3 moves we have got. And for this it is 1, 2, 3 and 4, right? So 4 for this, 2 for this and 1 for this. 1, 2, 4. So the sum is 7. So for index 0, 7 moves are required. Then if we check for this particular index, so this ball is already present in this box, right? So there will be no move counted for this. So we'll check for these two. So this will take one move, this will take 1, 2 and 3, right? So total 4 moves. Then if we check for this, so one move this will take and 1, 2 this will take. So total 3, right? See, when we are filling this, so we need to consider the balls from the left as well as from the right. Okay. Then if we check for this, so this will take one move, this will take one move, and this is going to take two moves, right? So total is 4 again. Then if we check for this particular box, so this is going to take two moves and this is going to take three moves. So a total of 5. Then if we check for this, so one move, 2, 3, 4, 5, 6, 7 and 8, right? So this is 8. So this is what our final answer looks like. This is what we need to return as our answer, right? So now here, as I said, for each of the index, you need to check that in which of the boxes one is there, right? And then what you can simply do is that you can identify the difference between the indices of them. So when I am calculating for index 0, right? So we have a ball at index 1, 2 and 4. If I will do the difference of all these with 0, so 1 minus 0 is 1, 2 minus 0 is 2, 4 minus 0 is 4. Then if I do the sum of all these, it will be 7. So this will give me the total number of moves required for moving all the balls to this particular box, right? If I am at this particular index, then I need to consider both the left boxes and the right boxes, right? So what I will do is I will take the absolute of 3 minus 2, which will be 1, 3 minus 1, which will be 2, and 4 minus 3, which will be 1. And if I'll do the sum of these, it will be 4. Right? So the simple brute force over here would be that for each of the index, I check all other indices, and wherever a 1 is present, I can add the absolute of the difference between the indices to my answer, right? So if I write the brute force, you can simply run a for loop of I starting from 0 and going till n. And then inside this, as I check, we will check all the other boxes, right? So we will run another for loop of j starting from 0 till n. Why j is going from 0 all the way till end? Because see, when we were at this particular index, we need to check boxes on the left as well and on the right as well, right? So that is why j is always starting from 0 and going till the last index, right? Now inside this, we can simply check that if the boxes of j is equals to 1, then in that case, whatever is the absolute difference between j and I, that we can add in our answer array at the ith index, because we are identifying the answer for ith index right now. So at the ith index we will update this difference, right? And when j will be same as index I, at that time j minus I will be equals to 0, so nothing will get added to the answer. So there is no need of putting an extra condition that I should not be equals to j, right? So this is what our brute force approach looks like. And since the maximum length of this box's string is 2000, so this will get accepted, right? And here this loop is running n times, this loop is running n times, all other operations are constant. So this is order of n square, the time complexity, and we are not taking an extra space. This is our answer array which we need to return. So we can consider that the space complexity over here is constant, right? Now let's try to optimize it and think of a linear approach. Now if you see over here, when this particular ball has to be moved to this index, it is taking one move, right? Now if I need to find out for this particular index, can I say that whatever are the number of moves it took for coming at this particular index, it will take plus one number of moves for coming to the next index, right? So basically there are some repeated work that we are doing, right? So we can optimize that, we can avoid that repeated work and go from n square to n, right? So what we can do is, so see, for each of the index, we need to identify how many moves from the left it is taking and how many moves from the right it is taking, right? So what we will do is that we will break it down into two things. First, we will identify that for each of the index, how many moves is it taking to move all the balls present on the left to that particular box. And in the second part, we will calculate that how many moves is it taking for moving balls from the right to that particular box, right? So first, let's find out for the left. So basically, if I am at this particular index, so towards its left, whatever are the balls that I have, I will find out that how many moves are required for moving all those balls to this particular index, right? From the left. And then similarly, I can find out from the right. And once I have that, I can simply add those values. If I will add those values, then I will get the total moves required for that particular index or box, right? So what we will do is we will take two variables, the number of moves currently, right, which will be 0 initially, and the number of balls, which will also be 0 initially, right? So now if let's suppose that I am at this particular index, right, and the number of moves that it took for moving all the balls to this index was x, right? So now when I come to the next index, then whatever are the balls present on the left, right, their moves will be increased by 1, right? Till this particular index, we were having x moves, right? So when we will come at this index, it will be x plus the number of balls, because the move for each of the ball will increase by 1 when we move on to the next index, right? That is why we are also maintaining the number of balls that we have, so that when we are updating this array, we will always update it with the sum of moves plus balls, right? So if you see, for index 0, their sum will be 0, so we'll update 0 over here. Now this is 0, this is not a ball, so balls will remain as is. Now we will come at the next index. Now here again, moves, balls both are 0, so this will be 0. But this is 1, right? It is a ball, so the number of balls will be updated by 1. Then we will come at this particular index, right? Now here 0 plus 1 will be 1, so we'll keep a 1 here. And now here we have a ball, so the number of balls will be updated by 2. And here we did one move, so the moves will also be updated by 1, right? So basically, when you will come at this particular point, in the moves you are having that till this point how many moves are required, and the balls are telling that how many balls did you have. So when you move to the next index, you will add these two, right? Because there will be one extra move counted for each of the balls when you move to the next index, right? So when we will come here, we will add these two, so it will be 3. And since this is 0, so the balls will remain as is, and the number of moves will be updated to 3. Then we will come here. Now here it will become 5. 3 plus 2, 5, and the moves will become 5. And since there is a ball, the number of balls will become 3. And then we'll come here, so it will be 5 plus 3, that is 8. And this will be updated to 3, no ball, and then we are done. Now we will try to identify for the right, right? So we will write from the right. So we will again take the number of moves as 0, balls as 0, and we will do the again same thing but from right towards left, right? So now here the sum will be 0, so we'll keep a 0 over here. Here it is a 1. First, the number of moves here is 0, so we'll keep a 0, but the balls will be updated by 1. Then we will come here. Now here it will be 0 plus 1, that is 1, right? So 1 move we did, and since this is 0, the number of balls will remain as is. Then we'll come here. Now it will be 1 plus 1, that is 2, right? So number of moves will be overwritten by 2, and since this is a ball, the number of balls will also become 2. Then we'll come here. So this will become 2 plus 2, that is 4. The moves that we did was 4, and the balls will be increased by 1, so it will become 3. Then when we'll come here, it will be 4 plus 3, that is 7, and then we are done, right? Now you can simply add these two, so it will be 7, 4, 3, 4, 5, and 8. This is our answer, right? Now, there's no need of creating these two arrays. What you can do is that you can simply create your answer array, right? First, you can update all these values, right? Initially, you can keep all the values as 0, and then you can update it from left to right. And then while you are going from right to left, you can update this same array, right? These values you only need to add in them, right? So whatever is the value you are getting, just add it here at this particular index. So you will get this answer, right? So in this particular case also, our space complexity will be constant because we are taking only one array, which is our answer, right? And since here we will be moving from left to right and right to left only once, so the time complexity will be order of n, right? So let's quickly look at the code. So first of all, let's take the number of boxes in n, right? Then let's create an answer vector for storing our answer. Its size will be equals to n, and initially all the values will be 0. Then we will take balls as 0 and moves as 0. Then we'll run a for loop of I starting from 0 going till n and I plus plus. Inside this, in the answer of I, we will update it with balls plus moves, right? And then we will update our moves and balls. So moves will be equals to moves plus balls. As you remember, whatever we kept at this particular index, that value itself we gave to the moves, right? And what is the value that I have given to answer of I? Balls plus moves, and same value I'm giving over here as well, right? Now if my current index in boxes, that is boxes of I, is a 1, then that means it is a ball. So I should increment my number of balls by 1, right? And we should update the moves first and then the balls. Why? Because if we update the balls first, then in this moves, this balls will be plus 1. Basically, whatever is the value here and whatever is the value in the moves, that will not match, right? So that is why first we are updating the moves and then we are updating the balls, right? And the same thing we will do from right to left. So we will again initialize balls and moves with 0, right? And now we will run a for loop of I starting from n minus 1 going till I greater than equals to 0, and then we'll do I minus minus. Inside this, we will do the same thing, but at the ith index, we are going to add it. Here we are just updating it, but here we will add it, right? What are we going to add? Balls plus moves, right? And then in the moves, we will update it to moves plus balls. And if the boxes of I is equals to 1, then we will increment our number of balls by 1, and at the end we can return this answer. So let's try to run this code. So the test cases are accepted. Now if you see over here, we are doing two passes, right? We are doing two passes, but we can also achieve the same thing in single pass. Why? Because if you see, in both the loops we are doing the same thing, right? We are just adding over here and here also, right? So what we can do is that we can combine them within one loop itself, and in both of these we can add, because initially the value is 0. So here also we can add an answer of I, and here also we can add an answer of I. So with that, the logic within both of these loops is same. The only thing that is different is the index, right? Here when I is 0, the other I, basically from right to left, my index should be what? It should be n minus 1 minus I, right? If you see here, I is starting from n minus 1. So whatever is my I right now, if I subtract it from n minus 1, I will be able to get the corresponding index from right towards left, right? So what we can do is that here we can take a variable j, and that will be n minus 1 minus I, right? So when I is 0, j will be at the last index. When I is 1, j will be at the second last index, and so on, right? But now the balls and moves will be different for while moving from left to right and different for while we are moving from right to left, right? So what we will do is that we will keep this for left. So balls L will denote the balls on the left, and moves L will denote the moves on the left, right? And then we will take balls right, this will also be 0, and then we will take moves right, which will also be 0. And then here we can do the same thing. In the answer at the index j we will update, right? So at the index j we will add, right? We will add balls of R plus moves of R, right? And then in moves of R, we will add moves of R plus balls of R, right? And then if the boxes of J is equals to 1, then balls R will be incremented by 1. And then we will update these as well. So it will be balls left, here also moves left, balls left, and then here also balls left. And then we can remove this, right? And then here also we will add a plus, right? So now let's try to run it again. So now we have optimized our approach from 2 passes to a single pass. Let's try to submit this. So it got accepted. Thank you so much for watching. Please like the video and subscribe our channel.